The horrors of not wearing an outer gold visor were dramatized in the science fiction movie Deep Impact.
The sun's rising behind you. It's coming up fast.
Phase shields down!
Oh, Christ.
Get the hell out of there!
Get your visor down! Alright, we got it.
Curiously, in his review of this movie, Phil Plait writes this about this very scene.
I suspect that this may not be totally inaccurate. I am not sure how close the comet was to the sun when this happened. I would expect NASA to give them sun visors, however, or build in a UV block to the visor. They were on the dark side of the comet, after all, so they would not have had their sun visors down, and he was admittedly too panicked to think of snapping it down. Still, a moment's exposure should not have so badly burnt his face. That was added for drama.
Phil Plait seems notoriously ignorant of the fact that on Apollo 17 alone, lunar module pilot Jack Schmitt was seen walking around on the moon for nearly an hour without wearing his golden visor.
Hey, Jack, can we see your gold visor up? You may want to put it down out here in the sun.
Well, I think I might. I can't see with it down. It's scratched.
YouTube user Green Magoo's pointed this out to Plait and asked him how long he expected Schmitt to last with his visor up. He reminded Plait of what he had written in his review of Deep Impact. But rather than responding along these lines, Phil Plait promptly blocked Green Magoo's from posting on his channel. It should come as no surprise why Plait refuses to discuss this. As Lloyd Malin states, Leonov should have been a charred, broiled cosmonaut. It cannot be overlooked that Leonov allegedly spent 12 minutes walking in space. Schmitt spent nearly an hour walking on the moon with no golden visor. Finally, the astronomers from Kurlang also point out that the horrors of James A. Michener's fiction book Space can indeed happen in real life.
There is a book, quite an interesting book by James A. Michener. Some of you might be old enough to remember James A. Michener, the writer. And he wrote a book called Space, which was a fictional take on the space race to a large extent from the end of the Second World War up until the end of the Apollo project. And in his book, he had an additional flight, Apollo 18, and those astronauts were killed. Two of them died on the surface of the moon because of a solar event, a huge amount of radiation bursting from the sun, which does happen.
As Bill Kaysing and Ralph Rene were able to establish previously, in the beginning, the Russians knew that the radiation encountered in cislunar space would be fatal to astronauts and cosmonauts. And by 1963, even with their superior lifting capacity, the Russians could see no immediate way of protecting cosmonauts from the lethal effects of solar radiation. This historical fact is documented in the 1963 book Journey to Tranquility. As Rene states in his book, This had to mean that not even the much thicker metal walls used on the Russian capsules could stop this radiation. How could the very thin foil-like metals used on our capsules stop this radiation?
Now, if Russia couldn't, protect their astronauts, and their craft and engines were much bigger and stronger than ours, then how the hell did NASA do it? With suits made of silicon rubber and an aluminum hull 2,000, 3,000ths of an inch thick?
Sticks and stones.
Yeah, sticks and stones.
The skin on the crew cabin was very thin, and that was all done because of weight savings. Weight was a very critical item that always had to be considered in anything that you did.
If you really took your finger and poked hard at it, you could poke right through the outer skin of the spacecraft. It was about the thickness of 2 layers of aluminum foil. But it's the kind of thing that you were reasonably cautious that you didn't jab any pointed objects through.
And as we established from Gregor Chamitov, even the walls of the shuttle and the ISS are not thick enough to block out the most devastating particles.
The radiation will certainly affect the seats, but actually inside the space, look at the background cosmic rays, which are the most devastating radiation, the heavier particles. We still get those with some shielding from the solar particles in here, but the cosmic rays still come through the space station.
One of the reasons for the thick walls on the shuttle and station is so that a sea-level nitrogen-oxygen atmosphere can be contained, like on the Russian spacecrafts. Evidently, the Russians couldn't block out radiation back then, and the 16 international partners can't do it today.
Equipment failures are just one of the many hazards of the mission. Another is cosmic radiation. Because totally shielding a spacecraft would make it too heavy, the crew would get about half the dose that an airline pilot gets over an entire career. Micrometeorites in space whirl around at speeds greater than 30,000 miles an hour. A strike by one smaller than a pencil eraser could cause disaster. And most ominous would be the powerful solar flares that send deadly ions throughout the solar system without warning. On Earth, the atmosphere stops most cosmic rays from reaching the surface, and all but the largest meteors burn up. Even the deadly ions from solar flares are deflected by the Earth's magnetic field. For travelers out of Earth orbit, there would be no protection. And most ominous would be the powerful solar flares that send deadly ions throughout the solar system without warning.
And yet, certain propagandists would have you believe that NASA could somehow predict when a deadly flare would erupt. On his website, Robert Brandig states,
"High-intensity solar flares could have endangered the astronauts' health, but these large eruptions are infrequent. Furthermore, there are statistical methods for determining the likelihood of a major flare during a given time interval. If NASA found an unacceptably high probability for a solar flare event during a scheduled flight, the mission would have been postponed."
Windley writes,
"A major solar event doesn't just cut loose without warning. It is possible to observe the weather on the Sun and predict when a major event will occur. And this is what was done on the Apollo missions."
Elsewhere on his site, Windley refers to the colossal solar flare of August 1972. It should come as a surprise to him that that very flare, as he put it, cut loose without warning.